Okay, so everybody, welcome to the Connected Intelligence Centre. For those of you who haven't been here before, our job is to try and build the capacity of the university to use data science and analytics in all sorts of arenas, one of them, of course, being teaching and learning. It's my pleasure to introduce you to Rose Luckin. Rose is a professor at the University College London in the London Knowledge Lab. She's passionate about learning and students from school age upwards. She's passionate about how we can assess people more effectively and not put them through the ridiculous 19th century exam system that we still inflict on learners in the name of assessment. She's passionate about AI and how it can be made really useful to the kinds of learning that many of us would consider important and which UTS considers important. Not simply automating teachers or students sort of out of the loop. She's going to say a lot more about that. It's going to be a sort of big picture kind of talk for a broad audience rather than a deep dive into technicalia, but I thought that was probably the most appropriate. Ruth, great to have you here. Try not to kill yourself.
Yeah, I'll try not to trip over that.
And we very much look forward to hearing your thoughts on AI and education.
Thank you. It's a pleasure to be here. Now, normally when I talk, I move around a lot, but my clicker won't work, so I'm actually going to have to stand still, which is going to be easier on your eyes because you won't have to be moving around. But yeah, it's a real pleasure to be here. I think the work that's going on here is fantastic, and I'm not going to be coming along telling you I know better because I don't. But it's very much about having a discussion, learning from each other, and realizing that we're trying to address quite a few of the same kinds of problems and issues. So the title of the talk is Who Moved My Intelligence? Because I was taken recently to look at the self-help literature for guidance about how to encourage people to start talking about artificial intelligence in a very generic way to get a broad audience of people. And I thought, what's the kind of thing that these guys who've been writing these books do? Because millions of people buy these books. How are they framing things? And I found this book called Who Moved My Cheese, which I thought was great because I love cheese. So I can really, feel the pain of somebody moving my cheese when I think I'm just about to eat it. But actually, it's quite an interesting little way of looking at things. So that's really what the title is about. And it's really trying to embrace change. And so the question behind the Who Moved My Intelligence is how education can use artificial intelligence to boost human intelligence, because I think that's the key to the way ahead. It's not about replicating what we can do with automated systems. It's about human intelligence and how we use those automated systems to make us more intelligent. So I was struck since I've been here, and it was actually Jane who pointed me towards an ABC program called the AI Race, which I'll refer to again in a minute, that there's a lot going on here in terms of AI, and a piece of research that was done by a company called Alpha Beta and that was used as part of this program, I noticed, was making statements like this about saving money, about more leisure time. When has that ever happened? We get all this tech, and do we ever get more leisure time? More satisfying. That would be good. We're going to have less workplace injuries. Excellent. I can see that being good. And this one struck me. Wages for non-automatable work are 20% higher than automatable work as a prediction, which is very much the same as saying it's those human skills that can't be automated that are going to be a premium in the workplace. So let's think about some of these things. And so one of the meanings of Who Moved My Intelligence is about how do we move our intelligence on? How do we advance it as humans and become more intelligent because of the possibilities afforded by automation? So I was very struck by this program, the AI Race, and I noticed that it had some academics from UTS on it, so you were a big part of the story, and it was obviously designed for public communication. And these were just some of the statements that were made in that program that just struck me when I was watching it as part of the real dilemma that I think education at all stages, but perhaps particularly within higher education, because so much is expected of higher education when it comes to leading the way. So schools should be telling us about this. There were some law students from, I don't think it was UTS, saying, gosh, we didn't know about this automation and nobody's told us, and hey, now we're going to have to deal with it all. There were statements about AI impacting on all jobs, whatever the stats are about, oh, your job's 13% automatable, or oh, your job's 55% automatable. It's actually going to impact on everybody. And 60% of students are studying for jobs that won't exist. I think that's been the case for quite a long time. Young people will be the most impacted by AI. Yeah, I think that's probably true. Must embrace AI and learn with it. Data is the new oil, which I'll come back to. A bit of a cliche, but I think there's something in that. But what does that really mean? Key skills will be being able to work with AI. Again, I think that's very true. If we're going to have a lot of automation, the consensus of opinion seems to be it's going to be likely to be more about augmenting human intelligence. So we're going to have to work with that AI augmentation. Creativity, emotional intelligence, these very uniquely human attributes, definitely likely to be at a premium. And conversation and social interaction. These are the things we're good at, and let's not lose sight of that. There were statements about needing to change the curriculum, with which I agree. But the key thing that I came away with, that I was so pleased to see in this program, was quite near the end when they said, but it's up to us. We make the choices. And I think that's the really important thing. It's the humans that make the choices about what the automation does. All this dystopian stuff that one reads about, machines taking over. No, it's up to us to decide. And that's the really important message I think we need to get across to educators. So I think from an education point of view, there are some real difficult issues that give us a bit of a dilemma. So we don't know what the jobs of the future are going to be. So how do we prepare our students? We know they're going to be different, but we don't know exactly what they're going to be. There's no consensus of opinion about exactly how AI will impact on the workplace. Yeah, we're moving to a space where most of the experts seem to think it'll be about augmentation rather than replacement. But exactly what does that mean? We don't know. Who's preparing the educators to understand enough to be able to help students or employees to understand? You may be way ahead of us here in Australia, I think you probably are, but it's not a lot of it going on. And how do we identify and assess the skills that we're going to need in 2 years, 5 years, 10 years, 20 years? Because of course assessment is always so important. How do we say, yes, this person is good at this skill that we now realise is incredibly important? So these are all difficult questions for educators, and yet so much will be expected of educators in this space. And you can bet your bottom dollar, if the students leaving universities aren't prepared for the workforce, the universities are going to be the ones who are going to be blamed. So we're in a very difficult position as educators, which is what made me think about Who Moved My Cheese, or Who Moved My Intelligence. So I'm just going to tell you a little bit about the Who Moved My Cheese book, because I think we need to understand something about the story to understand where I'm coming from. So it's a story about 4 characters, 2 mice and 2 humans. We have Hem and Haw, who are the humans, is I think where those names came from, people being indecisive, and Sniff and Scurry, who are the mice. And basically, these 4 characters live in a huge maze. And at different locations in this maze, there are piles of cheese. And everybody wants cheese. So fairly early on in the story, all 4 of these characters find a huge cheese pile called Cheese Station C. And Sniff and Scurry, get in there, they enjoy the cheese, but they don't sit back. Hem and Haw get a schedule ready, they decide who can eat cheese on which day, how it's going to be made to last, and it's all automated and operationalised, they have project managers, the whole thing. And then suddenly comes the day when there's no cheese left in Cheese Station C. So, cheese is meant to signify happiness, by the way. Sniff and Scurry accept it. Oh, okay, we've got to go on a long hunt, we saw it coming, we're prepared, off they go. Out into the maze to find more cheese. Hem and Haw just get grumpier and grumpier and grumpier. Why has this happened to us? It's not fair. Who's taken my cheese? Where's it gone? Haw occasionally tries to get Hem to think about moving through to look for more cheese, but doesn't want to know. Cut a long story short, Haw goes off on his own and decides to look for cheese. Sniff and Scurry have already found Cheese Station N, which is phenomenally large, so they're happy. Hall finds morsels of cheese which encourage him to keep going. He thinks about taking some morsels of cheese back to Hem just to see if he can encourage him to move on. After a while he decides to do this, but Hem still doesn't want to know. No, take your morsels of cheese away. I don't want to know. I'm just going to be grumpy and sit here. So Hall goes off. I will tell you the end of the story at the end of the talk, so you know what happens. But really, this business about cheese, it's all about change. And so the who moved the cheese, we could think of as who moves my intelligence. So rather than searching for cheese, we're going to think about intelligence. Because that's actually the key thing about artificial intelligence. We focus on the artificial bit, the tech bit, but actually the most important bit is the intelligence bit. And so that's the bit I want to think about today. And I think one of the things we have to do, and my first of two interpretations of the who moved my intelligence question, is this business of moving our students beyond those routine cognitive processing skills that are so easy to automate, so that we can look at how we can use AI to help us do that. And so this picture I use a lot, and it's basically trying to depict the situation of metacognition. Do I know what I know? How accurate is my belief about what I know? Do I know how I feel? How accurate am I interpreting my feelings? How accurately am I interpreting the feelings of other people? How do I know the best way to interact in this situation? All of this meta-level processing is something that humans can be very good at. They're not necessarily naturally very good at it, but they can be. If I say to you, where have you been this morning? You can immediately tell me, it's not difficult, you know. What do you know about AI? In this room, probably quite a lot. And you've got a fair sense of that. How well do you understand calculus? I'm not saying do you understand calculus? How well do you understand calculus? I know I'm not very good at calculus. But I know that actually with enough time and some help, I'll probably get back up to speed. And I could be okay, not brilliant, but okay. How are you feeling? I'm feeling slightly anxious because I'm giving a talk. I know I'm feeling slightly anxious. You're hopefully anticipating something interesting, asking some good questions at the end, all of those kinds of things. But you know that. But that's not the case with AI. AI doesn't have that metacognitive ability. I noticed that the academic from UTS on the AI race program suggested that AI could have emotional intelligence. I have to disagree. I think AI can feign emotional intelligence, but I don't think it's the same as having that. That genuine understanding of our own processing, our feelings, that is part of what's uniquely human. And that's the kind of thing we need to foster more if we're going to help move our students' intelligence beyond the stuff we can easily automate. And so humans can be capable of this metacognition, of this self-regulation, and of this self-efficacy. And one of the things that's perfectly clear from what we do know about the way automation is likely to change the workplace is that we can't predict the exact nature of what the jobs are going to be, and we're going to need people to be willing to be flexible, to willing to learn throughout their lives, however long those lives might be. So one of the things that we need to do, I think, most, is to help them be really good at learning, to be self-effective learners, to know what they know, to know how they learn. And I don't mean learning styles, I mean to know what works for them, when they need enough sleep, when they need to eat. Simple, basic things, and then much more complicated things. Do I find it better if I practice this particular type of skill and then I go to look at the big picture? Or do I find it better to have the big picture and then try and go down into the detail? All of these kinds of things. So whilst AI can't understand itself, what AI can do is help us to understand ourselves better. Because if we collect the right data and we analyze it and visualize it for learners appropriately, we can help them to use that to improve these human skills. And in my humble opinion, I think that's the way that we will best benefit from AI. And I don't just mean learning online. I don't just mean people plugged into computers, and that's something I don't need to say to this group because I know you're very well aware of this. But we can now collect data from all over the place. Passively, we can harvest data from social media, we can have sensors. Of course, there's lots of ethical questions that need to be answered in order to decide what's appropriate, but we can do this. And so, just for the next 10 minutes, I'm going to give 2 little examples where I'm going to go into a tiny bit more depth and detail, and then I'll come back up again. So, what might we be able to do? So, a long time ago, I built this little system. My daughter will remember this system. It was built a long time ago, and I was very lucky because I managed to get quite a few grants to keep on building it. And it was just a little simulation. You can see how old it looks. We haven't used it for about 6-7 years now, but it was a little simulated environment for 8 to 10-year-olds to learn about food chains and food webs, and they could add animals and plants to this little simulated world, and they could decide to give commands for things to eat each other, things to move, and it was all about looking at energy transferring from one organism to the next. The simulation could be in different levels of complexity, so you could have very simple relationships that would just be a simple food chain, and then the complexity of the world could increase and you could have food webs, and in the original version we had populations. But the point of it was to look at how we could help these learners be better at understanding what kind of difficulty level they were able to cope with, and to help them use the assistance that the system could give in terms of hints and tips and helping them to solve the problems, how good they could be at that. And we wanted to help them become better at managing themselves in this simulated environment. So this was very much looking at metacognition. This wasn't online, this was just a standalone piece of software. And so we built this kind of little open learner modeling, model I was called it, where you got an overlay of the curriculum. This is very high level, little detail, and you could go across each part of the curriculum and see what level of challenge you'd taken on as a learner and how much help you'd used, and then you'd get assistance from the software that would say, how about taking on something a little harder next, or you could use some more help. That was all individualized according to what they'd been doing, but trying to scaffold this metacognitive understanding. Very old, but actually surprisingly effective. Over many trials, we found the same thing happened. Students who had the system with the metacognitive scaffolding did perform better, and what was really nice was less able students did really well. Because a lot of teachers said, it's a great idea, but I don't think this group of learners will be able to benefit from it. But actually they did, and they did significantly better, which was interesting. So the reason I use this is to say, we have got a history of doing work that helps to scaffold metacognition, not just me, there's a lot of history there. We know we can do it, and we know we can use technology to do it, and being able to open up a learner's trajectory as they learn and give them help to understand themselves better could be one way that we can use AI to increase our metacognitive awareness and indeed regulation. So very simple, but actually effective. The second example I want to give is a very different situation, and this is much more up-to-date work, and in fact the last part of it is still work in progress, but I wanted to talk about it here, not least because I know you guys are doing a lot of work in the same area and you can probably give me some good advice. So we've been looking at collaborative problem solving, because again, this is the kind of thing that employers are wanting, that universities are doing more and more, and schools are trying to do more, but it's hard actually to teach using collaborative problem solving. So are there ways that we could help teachers understand more about what's going on in collaborative problem solving? Are there ways that we could help learners understand how they're performing in terms of collaborative problem solving to be better? So we've done a series of studies of small groups, 3 or 4 students, interacting to create things like this, which is a prototype for an interactive toy in this example. We've worked with school-age learners and with university learners and people in the workplace. They've used this Arduino technology, these little clip together, it's called Torku. It was some kit that Arduino kindly developed for the project, which was great. because it meant they didn't have to do all of those sticking little wires and things, which was good for students who weren't used to using Arduino. And so the students of all ages were set a variety of very open-ended tasks, so all of them were around building some kind of a prototype, some kind of an interactive prototype. And we were lucky enough to have a furniture manufacturer as one of our partners who built a specially designed data capture piece of kit that allowed us to capture lots of different data sources. So we looked at computer vision, so we tracked what was happening in gaze, where people were moving their heads. We tracked people's hands. You can see the markers on people's hands. We tracked what they did with the physical computing devices. So we looked at the interactions with the development environment and the interactions with the Arduino components. We also had a mobile system. We had some sentiment buttons so that people, when they were feeling things were going well, could press the "it's going well" button, and when it wasn't going well, they could press the other button. All of this trying to gather as much data, not suggesting that classrooms or universities would have one of these specially designed tables because they were quite expensive, but to try and find out if we could design some analytics that could do something useful and then work out, okay, what's the minimal system that might support this? What are the key things that would be useful for teachers and learners? And so we came up with things like this. Actually not as useful as you might want, so basically quite raw data about pressing the sentiment buttons, about different bits of the kit that they'd used, what did you use over time when they were using different pieces of the, actually I realise it's gone off the edge there, but the pink is to do with the way that the eye tracking, where people were looking, and we kind of tried to do some sort of higher level representation of the different phases of problem solving, but in essence it was pretty raw data and it wasn't terribly informative. It kind of gets people talking but didn't tell us that much. So then we kind of went back to this notion of what we're talking about is intelligence. Where's the intelligence in this analysis? So we thought about collaborative problem solving and what competences we would want to be highlighting to teachers and learners, and we would want to be supporting in some way. So we came up with these 9 competencies, some of which are based on the OECD collaborative problem solving definition and framework, are all extracted from the literature. So 3 competencies that related specifically to collaboration and 6 that related specifically to problem solving. So quite a simplification, but certainly grounded in what's been done before. And we developed a little tool that worked on a mobile phone or a tablet, whereby we could have human observers watching these groups, deciding when each of these radio buttons should be clicked, because they were observing, in this 30-second segment, they were observing a group establishing and maintaining a shared understanding, or they were looking at monitoring, reflecting and applying across one of these 3 collaborative phases. We had to train our observers to use this tool, I hasten to add, and actually on occasions we reduced the load on the observers so that different observers were only dealing with one of the columns to try and simplify it so that people got experience with the tool and could do something useful, because what we wanted was human observers to become good at using this tool so that we could carve up in 30-second tranches their evaluation of these groups' problem solving. But what we really wanted to know were the answers to these questions. So, are there observable differences between groups in terms of their non-verbal indexes of physical collaborative problem-solving interactivity? So on the one hand, we wanted the humans to be doing the rich analysis of what they were observing with these groups, but then we wanted to be automatically capturing data that would enable us to see whether there were aspects of what was going on that we could easily capture and automate that might map on to the higher level phases and competencies of collaborative problem solving. And what aspects of non-verbal physical interactivity are good predictors of collaborative problem solving performance? These were what I'm now going to talk about comes from this paper that's in press with Computers and Education on non-verbal indexes of students' physical interactivity. So this is now a really deep dive into some very fine-grained detail, but trying to see if that fine-grained detail of what people are doing when they're working together can tell us something about the higher order collaborative problem-solving skills that we really want to know about. So we looked specifically at 4 things. I'm only going to talk about 2 of them. So we looked at whether there was synchrony between what the learners in the group were doing. And this was learners of 3 students, because some work done by Schneider and P had suggested that synchrony when it comes to hand movements was a good predictor of collaborative problem solving. We also looked at individual accountability to try and see whether what an individual was doing was focused towards the goal of the group. We looked at equality to see whether you had one person doing all of the action and one person watching all the time, or whether there was more balance. And we looked at intra-individual variability, which was about saying, over time, does an individual student do a whole variety of different sorts of actions, or do they just watch all of the time? So this was looking at individuals over time, and then blending those scores together to try and look at the intra-individual variability of a group. And I'm only going to talk in detail about synchrony and intra-individual variability. And this is very much work in progress. So I'm optimistic about this work, but I'm not trying to suggest I've got all the answers. So the particular data I'm going to talk about was from 45 students, 9 secondary school students and 36 engineering students at a European university in Denmark, actually. They weren't all working at the same time. The 36 engineering students were working at the same time, and the 9 secondary students were working at the same time. They were all doing these open-ended tasks with the Tolku kit. For the secondary school students, the session lasted 4 hours. For the engineering students, it lasted 3 days. That's ever such a lot of data, as you'll appreciate. That data all collected, and everybody video recorded as well. And the groups had been formed very much to try and bring together individuals who are of a similar level of understanding of the subject matter, because we know that impacts on how effective they are at collaborative problem solving. And the coding that we did of the data was twofold. Firstly, we used human observers to use that little tool I've already talked about to mark when collaborative problem solving competencies were evidenced in what they were seeing. Then we also looked at 3 specific things that would be automatable. We looked at whether a student's hand was active with an object. We looked at whether a student was not actually physically active, but they were looking at the object or at the person. Could be a peer or it could be a facilitator. Or were they passive? So everything had to be one of these 3 codes. Very simple. So in this group, for example, you've got a 2, he's active, and then you've got 2 students who are a 1. They're not actually actively engaged with this piece of kit, but they are looking. They're not looking way off. They are looking at what's going on. And then, again, in these situations, you've got a student over here who's looking somewhere completely different. So we've got an 012, we've got a 121, we've got a 002, because we've got 2 of them looking somewhere different, these 2, and 1 of them active. Sorry, the pictures aren't terribly good. And then this one's a 202, because we've got 2 students engaged and 1 looking somewhere different. And these were all things we would have been able to pick up with that automated gaze and hand tracking software. So the human observers were asked to do the categorization, and then on the basis of that we were able to decide which of the groups could be described as good at collaborative problem solving, which of the groups were middling, and which had low competence for collaborative problem solving. And you'll notice one group's missing because we had a technical hiccup, which always happens. So the next two slides are a bit detailed, but I'm going to point towards the bits that I think are salient and say it's all in the paper if you want to study the detail, along with all the calculations, which I'm not going to go into the detail of here, but they're all available. So the dark rows are the groups that were rated by the human observers as being high competency collaborative problem solving. And the light grey, this colour, are the low competence. And actually you can see that if we look at the synchrony of being active, so when the group's active together, there's a much higher percentage of that kind of activity going on with the high competence collaborative problem solving group. So these are higher percentages. And if I come over here, and I know I've got a pointer, but I will walk around. If we look at the lack of activity, again, the dark shaded ones, the high school's different, but the universities, there's 0% of the time when none of them are doing anything. Whereas with the low competency, light grey groups, you have got some time when they're not doing it. It's the kind of thing that would be obvious to a human observer, but we're looking for ways that we can automate the collection of that information. And actually, if you have the time, this table is in the paper, there's some quite interesting percentages in there that raise a few questions. But definitely, it looks as if synchrony does seem to be correlated. I'm not saying more than that. There's a possibility. The second one's more complicated. And as I say, if anybody wants to know the calculation algorithm for this, I'll happily share it, and it's in the paper. But this was the intra-individual variability. So how much each individual learner did different things over time. And then we looked at how matched those were within a group. And again, particularly with so you've got the dark shading here, and this is where you want a low score because you want them to be similar across a group so that you're getting that possibility that there's shared action going on. May not be, but that's what we're looking for. And again, you can see with the high shading that these values are lower, with the exception of the high school students where this one's a lot higher, but actually that one's lower. So it's not foolproof, but it's looking interesting. And the last one of these is a chronology of a high caliber, low caliber groups with this intra-individual variability over time. And what I'm trying to show here is that there's a much closer track for the groups that appear to be good at collaborative problem solving, and a much wider gap between the individual students in the groups that have been categorized as low competency collaborative problem solving by the human observer. These are early findings, but I feel encouraged that some of this low-level analysis can be correlated with some of those higher-order collaborative problem-solving skills, which gives me optimism that we could produce something useful for teachers and learners if we pull this data together. Of course, how we represent it will be a big question, because we'll need to represent it in a way that's accessible to those teachers and learners. But it looks as if there's certainly good reason to carry on looking at this kind of data to see what we can do in terms of helping teachers and learners to be better at learning using collaborative problem-solving methods and better at teaching collaborative problem-solving methods. So I'm now going to come back up from the detail and say what I feel optimistic about is that AI can help us to refine the crude data. And what I mean by that is we went to the learning sciences, we went to understand more about collaborative problem solving, to ask meaningful questions of the raw data. I think personally we will get the most information by combining some of those findings around saying, okay, have we got synchrony with equality? I don't think individually, I think it will be that we will need to look again and do another layer of analysis before we get something that's really useful for teachers and learners. But that's where the AI comes in, because we're using the learning sciences, and then we will need to design the algorithms that will process the data at scale and take us forward. So that makes me think, could AI-informed analytics help us to monitor and scaffold the non-routine cognitive tasks and skills, such as collaborative problem solving, that will be at a premium in the workplace? So AI can't do it itself, but can we use it to help us become better at these things? So could AI help us to move our students' intelligence to be more sophisticated? So that's the first interpretation of who moved my intelligence, or let's move to be more sophisticated. The second part is much, much shorter. So, if data is the new oil, can AI help us to refine the crude data and help us be more intelligent as humans? Interpretation 2, much more quickly. Who moved my intelligence? We don't want this situation where AI takes away the human intelligence and we end up being dumbed down, which worries me a little bit. So it's about moving certain aspects of work to be done by AI, automated systems, and keeping some as being human. Generally, when I ask a non-AI expert audience, so not yourselves, what they think AI is, pretty much their answers fit into one of those. It's a robot, or it's an Alexa or a Siri, or the other answers tend to be scary or something I don't understand. But it's very tech focused. But actually, what we really need to think about in terms of AI is the human side of AI, of intelligence, sorry, the human side, and what it is that we could sensibly allow the AI to do that would help us perform better as humans. So if I'm in the workplace, what's my relationship with my AI peer? What's my relationship with the AI tools? How do I use them most effectively? And I think that's the question we need to think about, is how we equip students to understand enough about AI, and I mean all students, not just students who are studying something technical, but everybody, to understand enough that they know what to expect from the AI they work with and what they shouldn't accept from it. So I think that's a real challenge. And I think one of the key areas where this will hit very hard is in education. Because I noticed in the statistics that were calculated for the AI race program on ABC that I think it was 13% of a teacher or a lecturer's job was likely to be subject to automation. But I actually think 100% of the job will change, because I think we're all going to end up teaching different things in different ways. We're going to need to help people to be data scientists, to understand the data about their students and their teaching, and that's very much going to have an impact on the whole job. So I think 13% is a vast underestimate of the actual change it will make and how much of our job will change. So a while ago, actually back at the start of the year, I wrote a post for a publication called What Next? Yes, what happens next? And it was about how we learn. And I did it for a school setting. And it was all about an AI called Colin. I don't know where we came from the name Colin, but it seemed to be right for an AI, who worked with a teacher called Jude. And the idea that we were trying to get across was that this was a story about the future, but it was grounded in technology we knew was possible. And so the role of Colin was very much to be Jude's assistant. We use the analogy of Jude being the judo master and Colin providing her with the useful information. And it was very much about Colin being there, helping Jude to understand what had happened with her students before they came into the classroom, what they'd been doing, giving her sight of things that she wouldn't have had sight of afterwards, but also, as the class was going on, collecting, analysing data, presenting data to Jude in real time so that she could be the best teacher she could possibly be. And so this was very much using existing technologies to present this scenario. I've rewritten it as a version for higher education, because actually it's not that different. We still have lecture rooms full of students. We still need to know what, as a group, they're not understanding, what as individuals they're not understanding, in order to adapt our teaching and lecturing to be the most effective. So I'm not going to read it now. It's available on the blog for anybody who wants to do it. And then another way of looking at how we move AI, where we allow AI to be used, is a second piece of work that we're doing with a small company in London called Third Space Learning. And Third Space Learning came to us and said, we are providing one-to-one human tutoring. At the moment it's for children who are struggling with maths in primary school, so we're looking at 7 and 8-year-olds who are really struggling with some basic maths concepts in the UK. And so Third Space Learning were linking individual children in the UK to tutors in India and Sri Lanka, because tutors are cheaper in India and Sri Lanka, and that meant that they could provide an affordable service for state schools in the UK who don't really have much money. You may disagree with some of the ethics of that, but let's just go with that for the moment. And of course, a key part of the selling point for Third Space Learning was that they needed to be able to say, we train the tutors, we evaluate the quality of the tutoring. Because obviously I'm a head of a school, I haven't got much money, I'm being presented with this possible solution for my 10 year 2s who are really struggling with maths, but how do I know these tutors are any good? So a key part of what Third Space Learning needed to provide was a quality evaluation of those tutors, those online tutors, human tutoring, one-to-one, audio and shared whiteboard. So one way of going could have been to say, we'll automate the tutors, because that's even cheaper, isn't it? But we didn't do that, because one-to-one human tutoring is still better than any AI. The results for AI across the board demonstrate we can build systems that can tutor as well as a human dealing with a group of tutors, but not as well as a human doing one-to-one tutoring, so still premium. So what we've done instead, and it's still ongoing, is we're working with the company to help automate the evaluation. So at the moment they have a human evaluator evaluating every tutor every week. And if they don't come up to scratch, they're evaluated more than once a week. So what we're doing is building data collection and algorithms to help automate that process. Those human evaluators can then become tutors. And we automate the process. Obviously, we'll have a human check every so often, but this allows the company to scale, because they were unable to scale because they needed too many human evaluators and they couldn't get the people to do the human evaluation. If we take that bit out of the puzzle, well, they can get people who are willing to tutor in India and Sri Lanka, and these people can tutor the kids in the UK, and we can still do the quality evaluation. Well, what's even better is that that quality evaluation of each individual tutor can then feed into an individualized continual professional development program for those tutors. Now, this is ongoing work, but we're making good progress with it. That makes the whole thing much more affordable and allows this company to scale. And that's important because we're due to be 69 million teachers short in primary and secondary education across the world. So if we can find a way of getting tutors to children and helping companies like this to scale, then we can start to look at addressing that big problem. But we're offloading the intelligence, not by replacing the human teacher, but by looking at the evaluation. And it's all about ensuring quality at scale. And as I promised, I'm going to come back to the story of the four little characters, because I know you're all desperate to know what happened. Did Hem realise the error of his ways? Did Hoare find the massive cheese station? Yes, Hoare found the massive cheese station. Okay? And he thought, should I go back for Hem? Because I've now found this massive cheese station. And he thought, no, I'm not going to. I'm going to write messages on the walls of the maze and let Hem find it for himself. And the messages he wrote are the ones here. And I've tried to translate them for the who moved my intelligence question. So it was things like, change happens, they keep moving the cheese. So computers keep getting smarter and intelligent tasks are moving from human to machine. This will keep happening. So we shouldn't expect it to stop. We need to understand enough about AI. And you'll notice we need to understand enough about AI happens lots of times on this side, because it's a key thing that we need to help people do. We need to prepare for intellectual activity. We need to keep checking on our own intelligence. We never need to feel like we've done it. It's something we need to be checking all the time and growing. We need to adapt thoughtfully. And we need to move with the intelligence. We need to keep going. And this is the one I think the most important, and the thing that I want all my students to go away with. Enjoy intelligence. Because the experience of developing greater intelligence and being smart tastes good. Because what I'm worried about is that commercially it must be very appealing for companies to believe that saying to individuals who are struggling, oh, don't worry, you don't have to understand calculus, it's fine, we've got a system that can do that. You don't need to understand that, you don't need to be intelligent because we can do it now. And that's just so the wrong way to go. I think we need to use AI to make us more intelligent, not to dumb us down. So, sorry, did you want to take a picture of her? I just realised you get it. Intelligence is the real power. And I'm going to stop there. And I welcome any questions. I'd love to have lots of questions and comments. Thank you.
Thanks so much, Rose. Great sort of
yes, very
way of thinking about AI. Perhaps hopefully it's given you all a different angle on thinking about AI in what we do as core business here at the university. Okay, a few to Rose.
I was just really interested in that idea of metacognition not being a feature of AI. Surely AI is whatever the person who creates the system or has the capacity, at least at the beginning, that is the same as the person or the people that have created that artificial intelligence system, and it learns from there. So hypothetically, couldn't you argue that metacognition of the system, of the AI system, is equivalent to, at least at the beginning, the people that created it, and then it could actually grow?
Fascinating. Yeah. No, that's really interesting. It's kind of, now what I would go back to, so this is a really old philosophical thought experiment, you probably know it. John Searle's Chinese room. So man in room, Chinese characters passed in, windowless room, sorry, Chinese characters passed in through one chute. He's got a rule book, looks up how you translate the Chinese character into the English character, passes it out. Does the man understand Chinese? No. He's using a rule book. And that's been modernized for machine learning and neural nets. There's still the question of, and it does come down, I'm afraid, to consciousness, and so it is a philosophical point. Because yes, you could build an AI system with hardwired self-knowledge, but it then wouldn't learn. Now, if we then take a machine learning system, the machine learning system is still learning on the basis of pattern matching. Whatever the technology within the neural network, it's still doing pattern matching. And so, could you do some level of pattern matching that related to metacognition? But that could only happen with the knowledge that that system has, because it's your metacognition's not my metacognition. Do you see what I mean? So
it's not that it doesn't have metacognition, it's that the metacognition is whoever created it.
It's whoever, and therefore it doesn't grow.
Well, if it's learning, well,
because it wouldn't be because the machine learning systems don't have the power to reflect on their own knowledge. With the Go system that Google DeepMind programmed, it took them 2 months to identify the key false move. That's because it didn't know.
Yeah.
So even with those cutting edge deep neural networks, there isn't that level of self-knowledge, and there isn't the capacity to grow it. And that's the difference with the human self-understanding, is that we can get better at it. And at the moment, AI can't. There are people who believe it will be able to. I personally don't, on philosophical grounds, but there are plenty of people who do, and that's an open question. Maybe they're right and I'm wrong. But at the moment, in the same way that we have systems that can mimic emotional intelligence, but they don't actually have emotional intelligence. They're not really experiencing and having that meta level appreciation of their emotions as it relates to the person they're interacting with's emotion. So we can get part of the way, but we can't get all of the way. But as I say, there will be people who will disagree with me on whether that's possible in the future, but it certainly isn't possible now. So there was a really good, sorry, no, I won't, I can talk to you afterwards, I don't want to, no, go.
So, like the trial is at very early stages and really nice, quite promising results.
Yeah.
But, you know, it's very small scale.
It's very small scale, I know,
stuff.
yeah.
So how do we make that next step to these much more metacognitive abilities, and then associate with that? It's quite uncomfortable for students to be in those kinds of things. So they don't like being in groups. They don't like, you know, they like to have lectures where stuff just gets given to them. So how do we make that need for them to move into that sophisticated thinking being quite apparent to us without really scaring them into using that?
So yeah, it's a really important question, and yeah, it's what we're doing very simple at the start. You know, it's hopeful, but it's not the whole thing. Totally agree with that. A long time ago, when I first started teaching in university, I taught the only group work course that the undergraduates had to do, software design. It was the most hated course in the syllabus. It was really hard to get decent teacher ratings because everybody hated it because so-and-so didn't work and my mark was brought down because they didn't do their stuff and I had to do it all, and you know it as well as I do. Those very same students 2 years later, when they were going for job interviews, would come and say, oh Rose, that was the best course. I just went for an interview and that was the only course I talked about because what they wanted to know was... I think it has to come from realization that this is what you will have to be able to do. And therefore we get the buy-in in that way, because they will. I think in terms of, it's a long, what I'm talking about with those little is a long way from metacognition, but if it's a stepping stone and it helps us get to that next level, because what I really am interested in is what we can give people to help them do more for themselves. We're not going to give them everything to help them be more intelligent, but what can we give them that they can then probe and prod and question in order to get more intelligent, and can we use these as stepping stones on the way? But yeah, we're not there yet. Jane?
I was just going to say, if we start these processes thinking about working in teams, collaborative problem solving, then hopefully the thought is that by the time they get to university or into those final years of high school, that their group and collaborative problem solving processes will be really much better. So I see
absolutely
there in terms of that intensive work, certainly around what STEM in some places is endeavouring to do. So.
Yes, and we did a piece of work for a think tank in the UK at the end of last year, looking at collaborative problem solving across the different education sectors, and we spoke to a lot of teachers as well, and many of them believe they should be doing more collaborative problem solving, but are too nervous because the room gets noisy and I feel it's getting out of control, and I don't think I know how to do this. And I think there's a lot of issues, and part of what I think we could use the tech to do is to help them feel more confident that maybe when their manager comes along and says, oh, it's too noisy, they can say, yeah, but look at this, these group have done it. So I think it's very much in that space, because we do need to do it earlier. I agree.
Just a thought, because it struck me, there was a psychologist called Lukotsky.
Oh, yes.
But interestingly enough, one of the things that was kind of something that was looked at was, when we're young, we talk our problems out. But we seem to eventually self-censor ourselves, or censor ourselves such that we internalise our problem solving in our head. We often talk in our head about problem solving. Have you ever tried an experiment with actually getting these people as adults to actually talk out?
Yeah, self-explanation, absolutely. Incidentally, that little piece of software that I built was based on Vygotsky's zone of proximal development. But I didn't go into explaining. So it's really interesting that you bring Vygotsky up. But there's a lovely framework developed by Michelin Chi, CHI, at the University of Arizona, on self-explanation. And there's lots of evidence to demonstrate that self-explanation is a brilliant way of learning. And so, yeah, absolutely, encouraging people to do that self-explanation is a really good way.
I think it's interesting. I mean, it'd be interesting to see if you ever get a group to do that.
It's hard to get people to do it in a group because, or for many reasons, not least because the ones who would benefit most from it are the least willing to externalize something that might be wrong. So it's really difficult. It's actually something I think where computers can help, actually, because there is still the notion of a private relationship with technology where you might get students more willing to open up than they are when they're in front of
So what about
a bunch of other...
private student goes, why did you do that?
Yeah. Yeah, tell me why you did that, yeah.
Try to do that.
Yeah, it would, but...
That's what children do very well.
Yeah, it is. Why? My grandson, who's 4, is absolutely in that space. Granny goes, why have you done that? Why is that doing that? Why? And I try really hard to keep answering because it's so important that people ask why. But yeah, it would be. But self-explanation is really powerful. I completely agree. I think I saw another hand. Yeah, it was over here. Oh, and then Kalina.
Can there be too much of that issue problem solving? Because we get into a point where probably every single subject doing group work, and students now questioning why are we doing group work? And I always answer because industry's asking because everyone's not good at group work. So how do we overcome that? Or what are your suggestions to overcome or answers to it?
That's really interesting, isn't it? It's so classic, though. It's what we do, isn't it? We don't think, okay, we need to do some group work and we need to blend it with other ways of learning. We go, oh God, we've got to do more group work. Oh, we'll do group work everywhere. And I think that's the classic human reaction. Actually, I think the students are probably quite justified to say, why are we doing it for everything? Because it's not the answer for everything, but it is a good way of learning something in a more flexible way, and particularly if it's interdisciplinary group work, so that you learn to synthesize different disciplines, which is increasingly important. But yeah, I still think there is a time. I know that one of the benefits I've had from being here for the last 5 weeks is distance from my lovely colleagues with whom I do much group work, because there's still that important time for reflection and individual thinking. It's got to be a blend, hasn't it, I think? Sorry, that's probably not much of an answer to your question other than I kind of agreeing with the buck against everything being group work. Oh, hang on a minute, I know I saw Kalina and then there's 2 more questions, yeah.
Thanks for your fantastic work.
Pleasure.
I really enjoyed it and I'm completely aligned with your vision and your philosophy, so it's fantastic and there's a lot of things that I want to talk to you about. But just a quick question for now. When you evaluated, when you asked experts to evaluate your students working collaboratively, did you ask them to evaluate their collaboration skills or their performance of their artifact or whatever?
We didn't, well, that's not true. In the data that I've shown you, we didn't have the artifact evaluation at the end. We did evaluate the artifacts at the end as well, because it was part of a real learning experience, and unsurprisingly the artifacts that were evaluated as being the best were also from the groups who had the strongest collaborative problem solving competency set.
So the experts evaluated their collaboration skills?
The experts evaluated the collaboration and the problem solving competencies, and the reason we did do an earlier study where we had the same expert, it's amazing anybody was willing to do this, who watched all the videos and we gave them no competency grid, just said, will you watch and tell us who you think? Which was interesting, and it did map to the rest of the data, but it didn't really help us break things down, which is why we came up with that set of 9 competencies, 3 collaboration, 6 problem solving, because it gave us more of a framework to look at getting consistency across multiple evaluators. We didn't get them to assess the end product, but we did get the teachers' assessments of that end product. So it's true to say that the person who evaluated the end product was not the same person who evaluated the collaborative problem solving, and that might be a flaw in the methodology, but I think if you'd seen the outputs, it was pretty clear which the best ones were, so it was much harder to assess the actual collaborative problem solving. But it's a good point.
Just asking because like you were very low, similar things
Yeah.
And we provide another trying to take the moment of collaboration and ask experts to take the video of this, etc. And one of the things that needed more work was if you ask experts to evaluate the collaboration and if you use the same